Okay, now what about next question? So let's see that. Yes, question number 10. There are two sub-questions. Find the angle between the following pairs of lines. So whenever you ask the angle between pairs of lines, what you need to get the directions. That's the first thing you need to do. If you look at both the questions are about the directions of the lines in vector form. Fine. Okay, so let's see that. So question number 10. Let me see the first one. So for first one here, directions are the one that is vector B. We write here B1 and B2 because we have two lines here. Direction of the first one, that is nothing but the 3i cap plus 2j cap plus 6k cap. You must have realized the coefficient of scalar represent what? Direction of the line. And what's the direction of the other line? That is I cap plus 2j cap plus 2k cap. Right? These are the directions of the given lines. Let the theta be the angle between two lines. Angle between two lines. So therefore, which formula? The same formula which you have used for vectors. Cos theta equals to vector b1 dot vector b2 with modulus, remember, in the numerator here. In vectors we were not having the modulus, upon their individual magnitude. Right? This is what you need to do. This is a formula you know very well. Now just place the value and simplify, so you'll get the cos theta here, and from there we'll get the theta. Okay, so dot product. What's the dot product? 3 into 1, which is 3, 2 into 2, which is plus 4, plus 6 into 2, which is 12, upon magnitude of the first one. What's the magnitude of the first one here? That's nothing but 4, 9 plus 4 plus here's 36 into, what about this? 1 plus 4 plus 4. So cos theta equals to here 19 upon, this is 7 and this is 3, so we'll get the 21. So therefore theta equals to cos inverse 19 by 21. So you need to put in this form only, right? That's the angle between two lines. The only important thing is what are the directions of the given lines, remember. That much you need to do. The second question, just I'll write the directions for you and then you can do the same way. What's the direction of the first one? You just recall, this is a vector form of a line, this is a fixed point, lambda, and this is nothing but the direction. So you need to write the coefficient of the scalar. I'm just emphasizing on this. Okay, so directions are this. So directions are, what are the directions? Here, the first vector B, I'll call B1 because we are going to write two directions, vector B1 and vector B2. So B1 is given by I cap minus j cap minus 2k cap. And for the other line, it is 3i cap minus 5j cap minus 4k cap. These are the directions. I minus j minus 2k, 3i minus 5 minus 4k. Now once you have these two directions here, just use this formula, cos theta equals to vector b1 dot vector b2 with their magnitude upon individual modulus. Use this formula as I did here, so we'll get the theta from this. Theta equals to cos inverse. Just simplify this. Dot product you know very well now. We did it number of times. This into this plus this into this plus this into this. Just place the value and simplify. The question number 11. It's the same question, but there the lines are given in which form? Cartesian form, you can see. The question is same, you get the angle between two lines. So you are just going to compare with this x minus x1 by a, y minus y1 by b, equals to z minus z1 by c. You're interested in this ABC, remember. This represents the direction of the line. The numerator should be in this form, remember, x minus x1, y minus y1 and z minus z1 form, remember. Okay, so let me write here directions of the lines. There are two lines. One I'll call the vector b1, which is given by 2i cap plus 5j cap minus 3k cap. I repeat, 2i, 5 and minus 3 you can just write. And what's the direction of the other line? That is nothing but what? Just have a look there. Minus I cap plus 8j cap plus 4k cap. Minus 1, 8 and 4. There you have 2, 5 and minus 3. Let theta be the angle between two lines. Let the theta be angle between two lines. So therefore, which formula? Cos theta equals to vector b1 dot vector b2 with modulus in the numerator upon individual modulus. Right? That is what you need to do. So therefore, cos theta equals to, now let's do this. Here, what is dot product? Inside the modulus, this into this, which is minus 2. Minus 2 here. Plus here 40. Minus 12. Upon magnitude of the first one, which is root of 4 plus 25 plus 9 into magnitude of the other one, which is 1 plus 81 plus 16. I repeat the dot product. This into this, which is nothing but what? Minus 1. Then 5 into it, which is 40. And this is minus 12. Then magnitude of the first one, 4 plus 25 plus 9. 1 plus, oh sorry, this is not 81. This is 64. I'm sorry. 64 plus 4 square, which is 16. Now the question is simplification. So here, so numerator just gives us 26 upon, what about this? This is nothing but root 38. And what is this? This is nothing but 64 plus 16, which is 80 plus 1, so 81, which is 9. So therefore, what is theta here? Cos inverse 26 upon 9 into root 38. That's the value of the theta. It's not the standard value, so we need to keep in this form. Now, as far as second question concerned, I'll just write the directions for you. So your directions will be, directions are first vector b1, that's the direction of the first line. So you have 2, 2, 1, this is the direction. You can write 2i cap, 2j cap plus k cap. And what's the direction of the other line? That is given by vector b2. What is that? 4, 1, 8. 2, 2, 1, 4, 1, 8. Here you can see that the first line is already in the standard form. X minus 0 by 2, y minus 0 by 2, z minus 0 by 1. Then x minus 5 by 4, y minus 2 by 1 and z minus 3 by 8. So 4, 1, 8. And then just you do the way I did here in the previous question. Right? This is the fourth time you are doing the same thing. Okay. And the 12th question, you are given two lines in the Cartesian form. You are also given that they intersect at right angles. And you want to get the value of small p. So we are going to use the concept that the direction vectors are perpendicular. So we use dot product equals to 0. So to get the direction vector of the first line and the second line, you need to express in the standard form. That's the only important point here. What is the standard form? X minus x1 by small a. Now this is not in the standard form. So I'll multiply both numerator and denominator by minus sign. So x minus 1 by minus 3, remember. Take minus common with this and set here. That's what I did. What's the standard form? X minus x1 by small a here. So we have this equals to, now coefficient of y should be 1. Here it is 7. So I'll divide both by 7. So y minus 2 upon 2 by 7p. What I did? Dividing numerator and denominator by 7. So y minus 2 by 2 by 7 equals to, this is already in the standard form. So here this represents the direction of the first line, that is vector b1, let me call. What is that? Minus 3 comma 2 by 7p comma 2. That's the direction of the first line. If I write directly 3, 2p and 2, it's wrong, remember, because numerator is not in the standard form. Come to the second line. Is this in the standard form? No. Here you must have x minus x1. So you need to divide by minus 7. So x by minus 1 upon minus 3 by 7p. Dividing this as well as 3 by minus 7. Why I did by minus 7 division? Because this coefficient should be 1, remember. So divide by minus 7. So this become x minus 1 upon this. This is y minus 5 by 1, already in the standard form as it is. Here you must have z minus something. So take minus common, z minus 6 by, and take that minus sign with denominator. So now this will be the direction, and the direction of the second line will be here, minus 3 by 7p, comma 1, comma minus 5. Fine. The only important thing is the standard forms of both the lines, remember. If you write directly from this 3p1 and 5, it's wrong. Now what we do? We just use the dot products equals to 0. I'll write as lines are perpendicular. This is given to you. Lines are perpendicular. Therefore, the dot product equals to 0. Now get the dot product. What is the dot product? This into this. So you have here 9 by 7, this into this, into p, plus this into which, this is 2 by 7 into p, minus 10 equals to 0. So just by simplification we get the value of the small p. So if I take LCM here, 9p plus 2p minus 70 equals to 0. So this is 11. So what's the small p? That's 70 by 11. That's required value of p. Fine. Next question 13. It's very simple. You are asked to show that the lines are perpendicular. So just you show that the dot product of the directions equals to 0. So directions are, what is the direction of the first line? It is 7 minus 5 1. And direction of the second line, which is given by 1, 2 and 3, because both are in the standard forms, Cartesian forms in fact. So now we get the dot product. What is the dot product? b1 dot b2. So this into this 7, this into this 10 plus 3. You can see that it is 0. So here directions dot product equals to 0. Therefore lines are perpendicular. Lines are perpendicular. We had such question in the beginning of this exercise. Now next 4 questions. Question number 4. Get the shortest distance between two lines. So it must be skew lines. 15's shortest distance, 16 shortest distance, and 17 is about again shortest distance. So these 4 questions, 14, 15, 16 and 17. So in these questions you are going to find shortest distance, right? We find shortest distance, that's the question. Between 2 lines, right? So you just need to recall the formula for the shortest distance. Can you just recall the formula for the shortest distance? If you remember, I'll just write for your information here. The lines are this, for example, lines are this: vector r equals to fixed vector a1 plus lambda vector b1. So this represents direction. Vector r equals to fixed vector a2 plus mu lambda vector b2. The lambda and mu be 2 scalars here. Then the distance d, which is the shortest distance, which if you remember, inside the modulus, it is difference of these two. You can write vector a2 minus vector a1 dot cross product of these two directions, vector b1 cross b2, upon its magnitude. It's in fact the unit vector, because some concept of the projection is used in the proof of this formula. So this is the expression. The shortest distance is given by this difference of the two fixed vectors dot unit vector in the direction of the cross product of the given two lines, remember. So we need to get this, the cross product, and then its magnitude. This much we need to do here first, remember, right? In all these 4 sub questions, there are some sub questions also, but everywhere in these 4 questions, the single formula: get the fixed vector on the first line, its direction; fixed vector on the second line, its direction, and just simplify this. The only thing you need to see that there should not be any algebraic mistake, right? Then you can do very easily. Okay, so let's see the first question here. First question means question number 14 I'll be doing with you. So in the 14th question, I'll write here what's the fixed vector a1, because we have 2 fixed lines here. What's the first one? That is nothing but here I cap plus 2j cap plus k cap. Okay, what's the direction of the first line, which we write here vector b1? What is that? I cap minus j cap and plus k cap. Okay, and fixed point on the second line, which we call usually vector a2, which is here 2i cap minus j cap minus k cap, and direction of the second line, which is vector b2, which is 2i cap plus j cap plus 2k cap. Fine, let me check this. This is 1 2 1 1 minus 1 1. For the second line, 2 1 minus 1 2 1 2. Okay, this is fine. Now you know the formula, so first we find vector a2 minus vector a1. You need this. Okay, so this is I cap, this is minus 3j, and this is minus 2k. This minus is 2 minus 1 1, minus 1 minus 2 minus 3, minus 1 minus 1 minus 2. So 1 is this. Now what you need to do? You need to get the cross product. And now the cross product of the two directions, b1 cross b2. So you know how to do? This is just a determinant, you know, I, j, k, components of the first one, 1, minus 1, 1. Components of the second vector, which is 2, 1, 2. Okay, so here this I cap, that is given by minus 2 minus 1, minus 2 minus 1 minus, this is 2 minus 2 which is 0 j cap, 2 minus 2 which is 0 j cap, plus here 1 plus 2 which is nothing but the 3 k cap, 1 plus 1 which is here 1 into 1 plus 2, so 3 k cap. Okay, so you are getting minus 3 I cap minus 0 j cap plus 3 k cap. This is nothing but vector b1 cross vector b2. Now we need to get its magnitude. So its length here. So what is its magnitude? It is root of 9 plus 0 plus 9. So you can take 9 outside. It will be 3 root 2. Fine. Okay. Now we need to just put these values where? In the formula. So let's place this value in the formula. Okay, so shortest distance, let me write this here. Shortest distance between two lines, let me call that as small d, which is equals to, the formula, vector a2 minus vector a1 dot the cross product b1 cross b2 upon the magnitude of this one, that's magnitude of b1 cross b2. Fine. So gets dot product now here. Dot product of which one? This and this one, remember. So we are finding these two dot products. So here 1 into minus 3, which is minus 3. This dot product I am evaluating. 1 into minus 3, which is minus 3. Always plus sign. Minus 3 into 0, which is 0. Always plus sign. Minus 2 into 3, which is minus 6. Upon its magnitude. What's the magnitude? 3 root 2. So what will get in the numerator here? In the numerator you will get the 9, because modulus is there, upon 3 root 2. So finally you will get the 3 by root 2. If you want, you can rationalize, but in general this is the shortest distance, 3 by root 2. Fine. Okay, so this is the shortest distance between two lines. If you want, you can rewrite like this also, just by rationalization, 3 by 2 root 2. That way also you can write this is the shortest distance. Okay, so I think this is not a big task, not difficult. What you need to do, you need to write first these 4 vectors, a1, b1, a2, b2. Get this, get the cross product, get its magnitude, and just place in the formula. That's what all in all about the required solution. So about the other questions, that is 15, 16, 17, all are about these only, remember. In the 15th question here, lines are in Cartesian form. So first you need to observe that the line should be in this form, x minus x1 by a, y minus y1 by b equals to z minus z1 by c. It should be in this form, remember. Now you can see that the first line, it is already in this form. So let me write the fixed vector here. That is what? You can see it is minus 1, minus 1, minus 1. You might have noticed why minus 1, because there your plus sign. What's the direction? Your direction will be vector b1, which is given by 7, minus 6 and 1. Right? Just for your information, I'm writing here to show you. Here you have actually plus 1 by 7. So you need to rewrite this is like x minus minus 1 by 7. Here it should be minus sign, remember, that's why it is this. Fine. Similarly, you have y plus 1 by 6. So you can write y minus minus 1 by 6. You must have minus sign here. So this is nothing but the minus 1. And so on. That's why we have this. What about now second line? The vector, it is given there you already minus sign. So you have 3 5 and 7. 3, 5 and 7. And what's the direction of that line? The direction will be 1, minus 2 and 1. 3, 5, 7. And this is 1, minus 2 and 1. Now just use this formula. Which formula? Distance equals to difference of these two vectors, a2 minus a1 dot product. Here you have b1 cross b2 upon its magnitude. Now you can do as I did the previous question. So not a big issue. I'm sure you can do this one. It's a question of calculation of all these vectors, remember. Okay, so this much you can evaluate. Same way, question number 16 and 17. Okay, now 16 is already in the standard form, so I'll not be doing. But if you look at it, 17, it's not in the standard form, so I'll do 17 for you. Okay, in the question number 17, you are given the vector equations of these two lines, but they are not in the standard form. Right? It should be in which form? One vector plus scalar into the other vector. It is not in that form. So here lines are this. The first line is this. 1 minus t into I cap plus t minus 2 into j cap plus 3 minus 2t into k cap. Fine. So I'll just rewrite. What I'll do, I'll open the bracket. 1 into I cap, which is I cap. Here, let me write t into I cap, t into j cap minus 2j plus 3 cap minus 2t k cap. Now what we do? We take the terms about I, j, k. So one is this term, the other one is this, and the third one is this. So I'll rewrite like this. Your I cap minus 2j cap plus 3k cap. That's 1. Now from the remaining, here t is a scalar, remember. I'll take the t common. If I take t common, you have minus I cap. Here one is this, the other one is this, which is plus j cap. And here I'm taking 2 common, so minus 2k cap. I hope this is clear to you. I repeat, what I did, just have separated the terms involving t. Here I, here minus 2j, here 3k. What about t terms? This is minus I cap plus j cap, and here taking t outside, so minus 2 cap. Now you can see that it is in the form of one vector plus scalar into the other vector. So this represent what? The fixed vector a1, and this represent what? The direction of the line vector b1. So a1 and b1 you got now. Okay, and what about the other line, second line? What about the second line? Have a look there. So vector r equals to s plus 1 I cap, 2s minus 1 j cap minus 2s plus 1 k cap. Fine. I, j, k. Your s is a scalar, remember. So we need to separate like this here. If I open the bracket, your s I cap plus I cap, 2 s j here minus j cap minus 2s k cap minus k cap. I repeat, what I did, just I opened the bracket here, nothing more than that, remember. Now terms which are free from s, that's scalar, this and this. So here vector r, that is nothing but the I cap minus j cap minus k cap. I, j, k, and terms that involves, which terms involve s. One is this, so I'll take s outside, so I cap plus 2j cap minus 2k cap. now you can see that it is in the standard form, vector plus scalar into this I minus jk. What about this? This is I, this is plus 2j, and here minus 2k. So this is nothing but here, let me write on the next page. So what is vector a2 here? Therefore vector a2 will be fixed vector on the second line, I minus j minus k. And the direction of the second line, what's the direction of the second line? I plus 2j minus 2k. Right? Now you can do it, but still I'll be doing for you here. What we need to do first, we need to find which vector. You know, vector a2 minus vector a1. a2 minus a1 you need to do. Look at it, a2 and a1. So here you know the difference of these two here. This minus this, which is 0 I cap. This minus this, which is minus 1 plus 2, so plus j cap. Minus 1 minus 3, which is minus 4k cap. I repeat, this minus this 0, minus 1 plus 2, which is 1, minus 1 minus 3, which is minus 4. And now we need to get the b1 cross b2, the cross product. Okay, so you know that its determinant I, j, k. Here coefficient of b1. What are the coefficients of b1? Minus 1, 1, 2, you know. Just have a look at the minus 1, 1 and 2. What are the coefficients of b2? 1, 2, minus 2. So here your cross product, so I'm just evaluating determinant, minus 2 plus 4, which is nothing but the 2I cap, minus 2 plus 4, minus, this is 2 plus 2, so 4j cap. I repeat, minus 1 into minus 2, so 2 plus 2, which is 4, and minus sign is already there, plus here minus 2 minus 1, so you have minus 3 k cap, minus 2 minus 1. So this is the cross product. Now we need its magnitude. Therefore magnitude of b1 cross b2 equals to here root of 4 plus you have 16 plus 9. So it will be just root 29, we know. Okay. So now I'll write therefore shortest distance, that's d, equals to inside the modulus a2 minus a1 dot, here the cross product b1 cross b2 upon its magnitude, magnitude of this cross product. Okay, now get the dot product of these two vectors, remember, these and this. So 0 into 2, 0 into 2, which is 0, 1 into minus 4, which is minus 4, and here minus 4 minus 3, so it will be plus 12 upon root 29, and therefore we have d equals to, this is just 8 by root 29.